frictionless AI experiences for our clients, as well as the products that we develop. Today I want to talk to you a bit about getting value from your AI and machine learning use cases and some of the things that we're doing at Melio to drive this more broadly. Based on our own working experiences in the consulting space, and also backed by a lot of research, it shows that 87% of all machine learning models typically never make it into production. If we look at the remaining 13% of those models, we see an even scarier picture. The models cost a significant amount to deploy. Often, I think the research says $95,000. That's definitely over R1 million for us. It takes far too long to get deployed, and there are too many people involved in the deployment process, on average around 6 people. If the models aren't being deployed, they're not generating value. They are multi-million-dollar experiments sitting on an island just wasting away. So you take months to build it, you've hired a team of specialists, and you find that the result doesn't create the value that you're expecting. It's tough. The barrier to entry is high for most companies and is still viewed as a luxury, something reserved for high-tech businesses or large enterprises. Those AI/ML initiatives cannot generate positive business outcomes or result in poor or negative return on investment. This has a further downstream impact on future initiatives being greenlit and the confidence in the teams to deliver them. But does the blame sit with the data science and engineering team? There are many reasons for this. Many of them we'll touch on today. I think a lot of you have probably seen this picture or a version of it. This is basically the end-to-end technology landscape for machine learning solutions and software solutions. We really are spoiled today with the amount of options that we have, but this is both a blessing as well as a curse. It makes it difficult for teams that function well together, and solutions that can be deployed rapidly and at scale. Also, if you pick the top performer from each one of these blocks, it still does not guarantee real tangible business value. So let's maybe take a quick step back and talk a little bit about what we mean by value. According to the Oxford Dictionary, I went super simple with this one. Value can be defined as the usefulness of something, something that has a material monetary worth, or what someone is willing to pay for something. They're nice little definitions, so we'll use an example and we'll see if we can apply them to an ML project. Here's a very high-level view of the process that's typically needed to get a model into production. It's pretty high level. I don't want to get into too much of the details. I think it's so late in the day. But really, you start with some understanding of the problem you're trying to solve and what you're trying to predict. In this case, for this example, I've just taken being able to predict the share price of the JSE top 40 shares each day. So you'll go and you explore the data in the area, mostly to understand what variables you have and which variables have value. You'll look at some of the issues in the data, there always will be, and other data sources that could contribute to your solution. Then you build a machine learning model, using any one of the frameworks available today. I won't get into that detail. Once that is done, you have a model, it's a trained model, it can now be deployed, and you can deploy it in your cloud of choice, in Azure, AWS, or even something on-prem. But once you see it in production, you realize that the model's really not behaving in the same way that you trained it. It's not useful. The trader that would use it to predict shares isn't really able to use this model. This is a simple example, but I'm sure we see it every day. Based on the work that we do at Melio, we consult to both large organizations and smaller organizations, and we see this every single day. But we built the ML model, everything should just work. So let's take a look at our definitions of value. Is it useful? We thought so, but we didn't really know at this point how the trader would use the data. After deployment, the traders didn't actually use the model, so it was definitely not useful to them. Was there material worth? the solution doesn't work on any new data that we're using to pass through this model that was deployed. Training showed a massive uplift, but in reality, the model was only as effective as a naive model, basically guessing the price of the share price each day based on what yesterday's price was. Is there any other material worth? We could argue that the process to get to the model is reusable, and some of the components to do that. The reality is this never happens, as the components are usually coded specific to the use case that they're trying to solve for. Will someone pay something for it? It's probably already cost the company hundreds and thousands of rands through people costs. In hindsight, I doubt they would pay, knowing that there wouldn't be any monetary return on the solution. The scary part about this example is it likely took several weeks to complete the model, and then a further couple of weeks or months to deploy it. Only after this happened was the realization that there was nothing of true value to the organization. It's a simple example. There are many reasons why machine learning projects may not deliver to the expectations of business and other stakeholders. Let's explore some of these that we see in our clients' environments. From a business perspective, we see that often work is requested without any further involvement from the business side of things. They tell you things like, we've got some data, we want to do this, go forth and conquer. And that's the last time you really speak to them. We find that probably the most important aspect is having business committed and involved in the process of building these solutions. It's hard and maybe sometimes impossible to get, but it's without doubt the most important part. The second part from a business point of view is establishing those baselines. What are we trying to compare the solution to? Business now has given us some of the direction, but how do we actually compare that to something to know that it's been successful? Baselines help to establish what that norm is that you're trying to beat, and setting a baseline up front with business can help you measure against that. The third one is the vision of the solution. And how will the solution be used by the business to generate value? Is it a nice to have, or will it be operationalized? Will operationalization be well thought through? Deployment is typically always only considered at the end of a project. Those three things from a business point of view often cause a machine learning project to fail. From a technology and data aspect, we see that having poor control over the data and the model is one of the most significant aspects that cause failure. This is becoming so important to the success of AI solutions that a new movement has been started focusing on the data itself. Many of you will know Andrew Ng, the founder of the Google Brain Research Lab. He advocates for a discipline in machine learning called data-centric AI, which is pretty much putting data at the front. It's the systematic engineering of the data required to build successful AI systems. At Milia, we'll talk a little bit about what we're calling use case-centric AI. The second one, from a data and technology point of view, is that machine learning is a multidisciplinary field. It requires software engineers, DevOps, MLOps, data scientists, business specialists, often nowadays cloud engineers, with some form of infrastructure teams. It's often very hard to come by, and it's very difficult to get time from all of these skills during an ML project. At Milia, we advocate for building what we call tree-shaped engineers that are able to specialize in one area, but they're also able to work across other areas of the machine learning lifecycle. I'll share a little bit more about that just now. And then lastly, the actual performance of the model has to meet the business need in the real world. Trying to do real-time prediction on a large model that takes several minutes to do the prediction is not going to be of any value to the business. The skeleton in the room. And what we're really after is value. And how quickly can we generate that value? How long did it take us to get something tangible? How quickly can we get to the point of understanding if there's any value without taking unnecessary cost? The focus for the rest of my presentation will be around how do we accelerate this time to value. So what do we mean by time to value? Let's look at what value means from each of the stakeholders involved in the machine learning process. Business are looking for the impacts at the top and bottom line. So they're going to ask the question, how can we generate revenue or save money from this? From a data science perspective, is the solution accurate? Is it reproducible? The data science team is looking for value from the model that's being developed. We also have the engineering teams who are going to ask questions like, can the solution run reliably? Can it be optimized? Where will we source the process data for the solution to create this end-to-end process? The engineering teams are looking for how efficient, reliable, and responsive the model will be. They look at the engineering inputs, the process, and how the outputs can be integrated into downstream systems. From an infrastructure and operations perspective, they're going to ask what kind of resources are required for the solution to operate now and can be scalable in the future. They're looking at the resourcing needs to ensure maintenance, security, scalability, and availability of the solution is in place. So value really means something different to each of these stakeholders. We can group them into 4 pillars of value. Commercial value, and I think this is in the context of business, but you can swap out commercial value for social value, environmental value, or any other type of value that's directly impacted by the business that you're operating. The second one is functional value, operational value, and reusability value. So let's go into them a little bit more. Commercial value is increasing the number of customers that are being onboarded each day, or reducing the process time to onboard new customers. Functional value will be how the overall solution functions as it was intended or designed to do so. This means that it not only performs to an expected or an agreed level, but it's also usable to the end users. Often this will include the model as well as the user experience of the overall solution. Operational value is how reliable the solution can operate. A predictive model for credit scoring that takes too long to return a result, or is part of an ecosystem or an environment that continuously experiences downtime, impacts the value of the solution. Ideally, the administration of the solution should be automated, incorporating best practices from DevOps and MLOps. And from a reuse perspective, it's so important to machine learning, but so often that point that gets neglected. How many times have you worked on a machine learning project and you're starting everything from the ground up? We've seen it in large tier 1 banks, other manufacturing companies that dominate the market, even small companies. There's no one solution for this. And this is something that we're quite passionate about solving for, both from a South African point of view, but also globally. So we have 4 core pillars of value for machine learning projects. It's not really easy to optimize on all 4 of these. There are always going to be some kind of trade-offs. In my experience, the commercial value, especially in the business world, is the most important pillar, and is typically the foundation for all the other pillars. Often you have to justify some kind of return on investment before you can continue to develop the solution you have. So you've shown some kind of value before you can actually continue to develop it. But in this case, if you trade off against functional value, then you're cutting corners to get to the numbers. Revenue will be throttled as complexity to the user system increases. Model performance can degrade over time, which can result in losses instead of profits, if not closely monitored and managed. If we trade off too heavily against operational value, you've got great commercial value, but your solution won't be sustainable. It will be difficult to maintain code, infrastructure that is shaky, models that take too long to make predictions, and so on. If you neglect reuse, then the value you create is isolated. New work takes the same amount of time or longer to develop and deploy. There is a likelihood of key man dependencies. If your senior machine learning engineer leads the team, you're very likely going to lose a lot of the intellectual property and the capability needed to continue. So, how can we accelerate time to value? We see that these are all important aspects. Let's share a little bit about what we do at Million, and hopefully this is something that you can use in your organization. Starting with something soft, it's actually a culture shift. Something that's part of the mindset that you apply to the problems and the opportunities that you have in your organizations. For us, it's a culture of being curious. We learn from all of our failures and we grow beyond this. Our success is how well the team can bring each of the components together. We aspire to build a company made up of what we call tree-shaped engineers. Our culture is enabled by the people we work with every day. Our founder, Meralda Wu, she's sitting here in the front row, she leads by example, and she actually shared a very insightful article on LinkedIn. So I highly recommend that you connect with her and have a look at this article. It's quite insightful. Basically what we're saying is that you focus on building teams that are made up of tree-shaped engineers. That means you have a trunk, which is your core competency. For example, data science. Then you have an aspiration to go deeper in an area of your core. So that could be further into deep learning, NLP, or a specific framework. But the aspiration is what's important, and the curiosity that drives it. Once you've got that, you branch out your core with skills that complement the core. So for example, working across areas from a software engineering point of view, your CI/CD, your containerization, microservices, that allows you to be able to connect with other developers, and you're able to start talking the same language. Why do we love it? Well, handoffs are a lot more seamless because everyone does speak the same language. Innovation is sparked at that intersection of expertise, and you actually create a more empathetic and collaborative culture because you understand the perspective of those that you're working with, and you're no longer just throwing a ball over the fence. So to summarize, I've put in what I think encompasses today's presentation into 5 key recommendations. That this is something that I would live by in focusing on delivering successful and valuable AI use cases. Focus on value. This was always going to be there, it's the title of my presentation. But remember to ask yourself the value-based questions. You know, is it something that can solve the problem in a practical way? Is there some kind of monetary or material worth to what you're building? And what would you pay for it? What would someone else pay for that? And I think often we like to play at the cool tech, and we get into the detail without actually coming back to the business. Understanding what are the key questions that we're trying to answer for. How is that going to generate value for the area that you're working in? Very important to do that. Then always start simple and iterate from that. For example, starting with heuristics, not everything has to be a machine learning model. Often problems can be solved with very simple analysis. Start there and then iterate and build more complexity in if you need to. But definitely don't start with a complex 20-layer neural network. Involve the business. Business needs to be involved as much as possible. Even if it's a regular 2-weekly sync or a playback to business, they need to be involved throughout the duration of the project. We always try and advocate for, and this is difficult to come out in South Africa, but this is what we need to come together as a community, is to build data literate business champions that can become product owners of ML solutions. Because technology teams can't drive ML solutions to value. It has to be underpinned by business. Form a great team. understand, shape, and grow the team that's responsible for executing on these data-driven solutions. Spoke about the tree-shaped engineer. You may have something that works really well in your company or organization, but it really is about the team. The technology is something that can be learned. There are many platforms that we saw that can do that, but you really have to start with strong business involvement, iterative development, using a really great team. And the last aspect, which we said earlier is almost always neglected, is share and reuse. And that should become the norm in how your teams behave and engage with the work that they do. These are very simple principles to live by. They're scalable. It's not something that you do in a small organization only. This is something that can and should be done at enterprise level as well. How are we trying to accelerate time to value at Melio? I'd like to share a little bit more around a platform that we're building at Melio that we believe will help data scientists to accelerate delivery in their organizations. We call this platform Highwind. Highwind is an AI platform that helps businesses and data scientists benchmark, buy, extend, and sell high-quality AI solutions and the underlying assets that make up those. So just to give you a few examples, high-tech companies currently employ the best data scientists in the world. They use very sophisticated software. They have access to incredibly high-quality data. The result is very expensive models that are built, which are pretty much inaccessible to 95% of the rest of the world. The rest of those 95% of companies remaining tend to focus on what we call reasonable AI solutions, often using disparate tools and technologies, and usually suboptimal teams to deliver. This is pretty much what supports the fact that 87% of models never make it into production. It's from these 95% of companies that just don't have the right structure, funding, data, technology to bring it all together to create those really cohesive use cases that generate value. So what we're doing at Highwind is to create a platform that abstracts the complexity from the user, enabling a simple mechanism to discover solutions, benchmark, and find the best solutions, either as they are on the platform, as a marketplace, or you can buy them and extend them for your own organization. The goal for us is to create an environment to generate rapid business value. We're quite excited about the Highwind journey. We have a booth outside, so please come through and visit the team. We can share a little bit more around how Highwind works and how we want to create a really solid AI ecosystem and a community that I think is quite fragmented at the moment. And we really are driving that rapid business value and being able to bring use cases to life through this platform. That's what I wanted to share with you all today. Are there any specific questions you'd like to ask?
Also, I have a question. Does it work with this kind of APIs that people on the other side are supposed to develop to integrate to, and then on that, do you find in general, what is your expectation of developers in South Africa in general? Let's say South Africa is a smaller market. Do you think your average customer has the developers to integrate the platform easily enough?
Yeah, so we're targeting primarily software engineers, data scientists, machine learning engineers as the users of the platform. But really, we call it a use case centric AI marketplace, because what we're trying to do is solve for the use cases that create the value, and not the data and the models themselves, but how you bring them all together. And the platform itself will allow you to interact with very intelligent content creators that are producing models that are specific to your industry. It might be specific to a type of problem like a credit scoring application or a facial recognition challenge. The platform provides everything required in order to get running as soon as possible as a software developer. In addition, as a content creator, we're facilitating this process for the developers, and it can allow you to, or those developers, to resell the work that they've done in a very structured and controlled way that grows community and protects their own and intellectual property as well. And then finally, the solutions on the platform itself can be deployed and hosted by Highwind and consumed as an API from any other organization that doesn't want to build AI solutions. They don't have the teams. They really just want to consume something that may not be core to their business, but can add a lot of value. And we allow for that as well.
Here comes the first integration.
Thank you very much. Just a question around the commercialization of your API calls. I'm assuming it is on your website as well. Maybe just elaborate a little bit on how that works.
Sure. So Highwind is an AI marketplace platform. So a lot of the pricing models that we would allow for are defined by the creators themselves. So we support them. The platform will take a small fee as part of that. But really what we want to do is make the use cases more shareable and discoverable and reusable across the different use cases and industries within South Africa and globally. Does that answer your question?
Yeah, we'll have a conversation.
Sure.
So that means that Highwind is probably a platform as a service as well as software as a service. Is that the model?
The platform itself is something that we'll manage and we'll present it as a software as a service. We'll have two types of deployment options. A public marketplace for those that want to work on less sensitive data and solutions. Your freelance type data scientists can build really strong solutions and promote them on the marketplace that businesses can buy or extend in their data science teams or just consume as an API. For more enterprise scale, we offer private deployment options where the marketplace will be a self-contained, closed ecosystem. And I think that will work really well for like your tier 1 banks, your larger enterprises that are struggling to generate rapid value from their use cases and less. We're trying to remove reinvention of the wheel at the end of the day. So we want teams in those enterprises to be able to share and collaborate together more effectively. And obviously, depending on which option you go, the pricing would change according to that.
We just agreed there that I think it's a good idea.
Cool. Hi. So how do you vet the developers and remove any biases and conflicts that they might come with?
Yeah, so the team that we have at Vimeo will provide the quality assurance reviews to make sure that what gets published on the marketplace will go through a process to make sure that, especially from a data perspective, that there are no issues in terms of regulations. But typically everything that you use on the platform will be private until you want to publish it to the marketplace and make it available. So you do have control over that. And as a content creator, you would also have control over the pricing model that you'd like to use. And that would come with the protection of the data and the assets that you have too.
What drives me to you as opposed to going to something like an AWS marketplace, AWS's data marts, GCP, Azure? What gives you the edge over those existing massive platforms?
I think there's still quite a large barrier to entry for companies to use those services, especially from a technical perspective. They're still not that easy to use. And we find that most of these platforms, I think even I was in the IBM presentation earlier today, they don't really have the right discoverability and reusability across a use case perspective for AI solutions. It's very much about the data, the feature store, the models, how do you monitor the models, how do you retrain them. What we're trying to do is bring that all together to solve a use case that generates value, and bring those components together and make those aspects reusable, and also give back to the community in terms of their own way to market these and sell these. In many ways, we'll work together with those providers. We're not trying to replace them. So a lot of how we want to deploy the solution will be multi-cloud.
Do you support Edge AI? So models on the edge?
So I think those are one of the use cases that we'd like to explore. There's no reason why we're not. So we are building the platform on a scalable backend. But as you know, Edge does require a lot of latency. One of the things that we will have available on the platform is what we call our benchmarking functionality. And the benchmarking functionality allows you to deploy your model and test that against other models that are already there or existing solutions available in your cloud providers. Those benchmarks can help you to understand what would the cost be to deploy this in a Google or GCP, what would the latency be if we did deploy it, and what kind of performance would we get out of the model. We will use things like AutoML to benchmark that, as well as existing models that are already on the marketplace that you choose to benchmark against.
Anyone else? No? Good. Thank you very much.
Thanks, everyone.
Sounds like